being very competitive relations, and almost always results in what we call a lose-lose equilibrium. In game theory, we have this idea that in order to really get win-win, you have to have cooperation and collaboration, and particularly, you have to have open sharing of information, I mean commercial information. And we know from design and build that people protect themselves from risk, commercial and schedule and other, by withholding information, maintaining the information as a weapon against the other side. Okay, so I hope I've painted a relatively acceptable view of how construction operates in, let's say, 90% of the industry around the world, apart from the few superstar projects where they might have integrated project delivery, and maybe by now 30-40% where they might be using BIM in some good ways, and some other things. But in terms of the hierarchies and the organizations, that's where we are. So, digitization. This is a construction robot. Its name is Tamir. Tamir stood for Technion Autonomous Multi-Purpose Interior Finishing Robot. And that robot was the focus of a very intense research project in 1991. Mirek probably knows Abram Warshawski and Yechiel Rosenfeld and others who were engaged in that research. They were able to make the robot paint. They were able to make it lay tiles. Not very well, but it worked. Ronnie Navon too, of course, and others. But this never became a commercial venture. In fact, the robot itself is sitting in our atrium in our building right now. It's a relic. The reason it never worked was that the economies were such that the amount of time required to set up and feed it the information and so on worked out to orders of magnitude more expensive than having a worker lay the tiles in a tenth of the time. But what really held it back was the information block. I mean, of course, things have improved since in the 30 years that have passed. But today there are commercial solutions. This is an Israeli interior finishing robot. It now works on many construction sites. It can do spray painting very well. It can do plastering very well in controlled conditions. But the key thing about it, and I think I put in, no, I didn't, video, you can look it up online. The key thing about it is that it is utterly dependent on having good information models that can go through the various algorithms to set it up in minutes so that it can then begin painting and working right away. And it does not need inordinate amounts of software programming and information keying in. And so these are now commercial solutions. Another technology. This is 3D cameras. So we're able now to use 3D video cameras, walk through a construction site, acquire the information. Oh, that'd be great. Acquire the information that looks like this. Thanks, Anita. And as a result of that, we can then determine what has been done. This technology only works when there is a BIM model over here or over here reflecting the real situation, the as-designed situation in the building, and then there is software that can compare using computer vision ideas, and it can then tell you where the images are, when they were taken, and it can give you a dashboard of which tasks are being begun, which are done, which products are done, and so forth, and a whole range of information. There are probably 3 or 4 companies doing this around the world now. One of them is BuildUps. It's an Israeli startup, and again, entirely dependent on digitization of the design information. Here is another one, another startup company that's begun succeeding around the world. What they do is they have a laser projector. It's a scanner and a projector, but you can take any design and lay it out on a construction site using this projector. They call it the beamer. And so I'll finish that. The point I want to make and leave you with is information is key. Information is the lifeblood of any kind of automation for construction of this kind. And mostly we need information that is either in BIM models or is being derived from BIM models. So, what is digital twin construction in that case? What is a digital twin? I'm helped by the fact that Chu before me this morning defined it a little bit, and she defined the difference between a digital model, a digital shadow, and a digital twin. And perhaps we can use this to have the idea. And I give credit to a colleague at the University of Cambridge who prepared the slides, the 2 or 3 slides. We have a physical locomotive, the train. We have a digital twin of the train. We take all the information from the sensors that are mounted on that locomotive. We have the digital twin. We can use the digital twin for 2 things. We can run simulations of what might happen on the basis of the patterns of data coming from the physical twin. We can also use long histories of digital twin information from other locomotives where we know when they failed or broke down or something, so we can use machine learning to identify patterns in the data that predict the failure, what Chu called the prognostics, and then we might be able for our particular locomotive to stop a month before the failure and do proactive maintenance rather than reactive maintenance. But then the other side of it is this thing of interventions. We might find that, as Chu expressed in the HVAC system, something is not going right in that system, so we can directly intervene and modulate a valve, change something else, and change the way the locomotive is running. Make it more fuel efficient while it's going. So this two-directional, bidirectional monitoring and control, that is the key thing that differentiates perhaps digital twins from digital models or shadows or anything else. But here we can do something interesting. If I have a digital twin of the locomotive, and I have a digital twin of the signal system and of the track, then I can start to merge them. I can start to say, for example, well, when I see the vibration sensor on the locomotive giving a knock at some particular point along the journey, and that comes from all the locomotives, well, maybe I have a fault in my track. And if I know that there's something on the track that caused some vibration in the locomotive, I can see it both ways. And I can use it then to operate both the tracks and the signal system entirely all together in ways that I could never do before. So I can run this as a system of systems. And then if you think about that one more level, I could say, well, I have the air system and the bus system and the railway system, and I can tie them together. And I can say, well, when do I need trains to leave from the airport? Well, maybe I can monitor the passengers getting off the planes and time it better and have the capacity at the right place at the right time. And it's dynamic, it's not forecast, so it's emergent. So the system responds within the system. And then, of course, I can say, well, if I have a system of transporting red and buildings and blue and something else, and I can tie them all together. And in the UK, they're talking about digital built Britain as being a long-term strategy of achieving a situation where we have digital twins of lots of different systems in our environment. It could even be health systems, it could be education systems, it could be all kinds of things, and tie them together. And they talk about design, build, operate, and integrate. Okay, so much for trying to define digital twins and digital twin systems of the future. Now let's talk about digital twin construction, digital twins in construction. Well, again, we can talk about the construction site when they're building the bridge. We can monitor it using a range of different tools, compile a digital twin of that, and then use that to drive the construction itself. Because one way of effecting change in the real world is not only through automatic operation of valves or machines and so on, it's also through operating people. And I don't mean to say that people are turning into dumb kind of mindless things, but people are people and they're workers, but they can receive their instructions from digital twins. This is not different from, if you imagine, I know that's not perhaps active in Istanbul, but imagine Uber or other taxi operating systems, then the operating system is telling the drivers where to go and what to go and when to go, or any kind of delivery sort of system, and many others where people are receiving optimized instructions from a computer algorithm. So if I think about this, we cannot, not only can we distinguish between the physical and the virtual, we can also distinguish between the status and the intent. And the intent is what we intend to do, and in construction that means everything to do with the design of the building or the planning of the construction. So if I use this array or this graph to say intent, status, physical and virtual, then up here I can put my project intent information, BIM models, construction plans, purchase orders, bills of quantities, everything that is telling people what we intend to do. In this corner, I can put, I'm in the intent, but I'm in the physical, right? So I could put a physical model, a scale model. If I build a scale model of the bridge and say, oh, that's what I intend to do, and I can test it and simulate it, try it, that's my physical intent. It's physical expression of my design intent. And then I can build. So I can build a building, a bridge. It's all controlled and run from the project intent information. And then, of course, I can monitor it. If I monitor it, I can get my project status information. So now I have virtual status information. I think, or I recommend that in construction we consider this side, this whole side here, to be the digital twin, expressing both our intent and the status of what we've done. Of course, one of the big benefits is that I can compare these two. I think I have that. We can compare those two, and then we can say, yeah, we're doing what we intended, or we're doing better than we intended, or worse, or something. But I can also say, well, it's not going quite how we thought, so we can change our project intent information for the next cycles of construction. Because I can say, well, I can change the design. I've built 3 floors in my building. The bathrooms took too long to build. I realized that the